Hello, good morning, and welcome back to your very own channel, Geeks for Geeks. I hope I'm audible and you all can hear me. If there's anyone who has joined, please let me know if you can hear me or if you can see me clearly. You can just give me a heads up if you can hear me and if you can see me. So, what are we basically doing? So, we have been Geeks for Geeks that we have started something called as a marathon session, where basically on every Sunday we are basically doing some of the other marathon sessions on JavaScript, on basically tech stacks related to web development. So when you see tech stack related to development, it starts with HTML, CSS. So we have skipped HTML, CSS because I think you can go and learn HTML, CSS, picking up a playlist from Geeks for Geeks itself. But we thought of starting with JavaScript. So this is the third session. So we have completed one session on basics of JavaScript. Then we completed one session on advanced JavaScript. So in the basics of JavaScript, we covered uh, things like the different variables which are there in JavaScript. Then we covered uh, arrays, strings, different data types, objects. We covered functions as well. And then in the advanced session, we covered higher order functions, right? And we did a couple of exercises as well. In the basics, we covered the conditions, the for loop, right? And in the advanced, we covered higher order functions. We saw some methods of arrays as well. And this is the third session, basically, where we are doing asynchronous JavaScript. We learn what async JavaScript is and how basically it works under the hood. So we are planning to do these kind of sessions on every Sunday. If the response is quite good, we will also start it on Saturdays and Sundays as well. Just to let everyone know that at Geeks for Geeks, basically we have full stack courses as well, right? It is a live session which happens every weekend, Saturdays and Sundays, and there are good quality mentors. I also take sessions, so it is a full stack session. I think there are 30 sessions, which goes up to a span of 2.5 to I think three, or not 2.5. I think it takes 3.5 months to complete the entire course. There are recorded courses as well. I have a course on JavaScript and React.js, so you can go and watch them. Okay, so without any delay, and if you have any questions, you can put it in the chat. I am basically reading the questions that are coming in the chat as well. Okay. Hello. Hi. Good morning, Nitesh. Uh, Nitesh is a student of mine. I know Nitesh is basically from my current batch. Um, cool. So yeah, let's get started. I'll start sharing my screen, and then basically we can directly jump right into the code, understand what async JavaScript actually is. Okay, so let me share my screen. And in the middle of the class, anytime you have any doubts or any questions, please let me know. I will try to explain it in the best possible way. Okay. Okay. So today we'll be covering something called as async JavaScript. Okay. So firstly, what is async JavaScript actually means, right? Async JavaScript or asynchronous JavaScript is something where something is not in sync, right? Something is not in sync, right? In JavaScript, as we know, everything is executed line by line, right? It does not jump or it does not do some anything like that, but everything is executed line by line only, right? You can't unlike okay, I actually don't remember a lot of C, but in C I think, or not in C, I think in some programming language I basically had I used to see a line of code of jumping also, to from one place to another place, from one point to another point, jumping from one point of the code to other point of the code. I do not remember in which programming language it was. It was by far, I only know JavaScript and Python. These are the only two programming languages I know. Okay. So but in JavaScript it does not happen like that, right? JavaScript code executes line by line only. right? Whatever it is, it executes line by line only, right? So when something is executing line by line, that means it is synchronous, right? So JavaScript basically is called as a single threaded synchronous language. Okay, it's called as a single threaded synchronous language. Okay, when I say it's a single threaded synchronous language, then how will this asynchronous come into picture? Okay, by definition, what I'm saying is that by definition, I'm saying that JavaScript in itself is a single threaded synchronous language. When you say single threaded, that means everything is executing line by line. Okay, when you say why things are executing line by line in JavaScript, it's because it's a single threaded language. That's why it's executing line by line. But now on top of single threaded, I'm also saying that it's a synchronous language as well. When I say synchronous language, that means it cannot jump from one point to another point. Okay, it has to be that way only. Okay, but there is a feasibility of asynchronous JavaScript also. What is asynchronous JavaScript? Asynchronous JavaScript basically is that you basically um, do something not in the sync, right? You basically just uh, hold something, right? And you basically jump onto another part and start doing that. For example, let's say uh, I'm performing an action, and in the middle of that action, basically I have to call an API. Let's say on the click of the button, I have to call an API, okay, or I have to get a data from an API, or let's say when I'm clicking on the button, I have to wait for some second and then execute some line of code, okay. So this basically part is called as an asynchronous part, right? Getting a data from an API, or creating a delay, waiting for some time, or creating a counter, creating an interval. These basically actions are called as an async JavaScript. Okay, but let's say when I click on the button and I have to call the data from and I have to get the data from an API. So getting a data from an API may take certain amount of time. Okay, sometimes it takes milliseconds, sometimes it takes 1 or 2 seconds also. Okay, if the API is quite slow, it might take time. You might have seen those loaders. It might sometimes it goes for 1 or 2 seconds also. Okay, so you might have seen all of those things. But is it a good thing? Like, so for example, if I'm getting a data from an API, so should I stop JavaScript? Should I stop the engine that you should not execute the further lines ahead? Okay, that is not a good thing. Okay, that is actually not a good thing where I'm basically stopping JavaScript from executing the lines below. Okay, and that does not happen in JavaScript also. So what happens is that even if I'm doing an async call, the remaining things basically will keep on happening in JavaScript. Okay, let me give you an example. Okay, so for example, let's say if I write over here a console.log of hello. Okay, let me just see if everything is working fine or not. So I see a console log of hello over here. Okay, now let me do an async action. Okay, so in JavaScript, I can basically create something called as a timeout. Okay, so I can basically create a delay. Let's say I want to create a delay of 2 seconds. Okay, and so how does set timeout work? Basically, set timeout takes two things. It takes a callback function. So I'll create an arrow function, right? And then it takes a delay also. So what does this delay? It will take a delay in milliseconds. Okay. So this delay is in milliseconds. So it is 2000 milliseconds. That means it is 2 seconds. And let's write over here console.log um, high from timeout. Okay. High from timeout. And after 2 seconds, I'll start after 2 seconds. So what happens over here? What does set timer do? So this callback function will be executed after 2 seconds. Okay, this callback function would be executed after 2 seconds. So let me save it, and if we go over here, so if you see it gives hello. Okay, let me refresh it. It gives hello. Now after 2 seconds, it is giving hi from timeout after 2 seconds. Okay, if you're not able to visualize it, let me make it 5 seconds. Okay, so now console log hello. Let me refresh this over here. So hello, and then after 5 seconds, it will give me hi from timeout. Okay, 5 seconds. So 1, 2, 3. Yeah, I was counting slow. So hi from timeout after 5 seconds. Why? Because I've okay no, it gave after 2 seconds only. I didn't change it five over here. I just changed the console to five. Quite silly of me. So hello and hi from timeout out of 5 seconds. So let me reload this. So 1, 2, 3, 4, 5. So after 5, yeah. So after 5 seconds, it comes high from timeout after 5 seconds. So now was it what it is what is it doing? Okay, so this is an async. This is an async action. Okay, okay, where basically uh, this is not going in sync. Okay. Now the question over here is what is happening? Is it making the JavaScript engine wait for 5 seconds and stop all the work? Okay, or does JavaScript engine continue executing the further line of code also? So let's see that also. For example, let's say if I write a console.log of buy over here. Okay, so there can be two possibilities. It will execute console log of hello. It will keep the engine wait for 5 seconds. Then it will log high from timeout after 5 seconds, and then it will log buy. Okay, this is one possibility. The other possibility. So now this possibility is not good. Okay, why? Because you're doing a console log of hello, and then you're making the JavaScript engine wait for 5 seconds, and JavaScript engine will be idle for 5 seconds. Okay, it will not be doing anything. It will be waiting for 5 seconds ideally and not be doing anything, and just after 5 seconds it will just log hello, and then after that it will do log by. But is it a good thing? So obviously it's not a good thing. Why will I want my JavaScript engine to wait? Okay, why will I want my JavaScript engine to wait? Okay, I would actually want it to log hello and then by, and afterwards it should log this console log high from timeout after 5 seconds. So does it work in that way? So let's see it. Right, so if you see, it does work in that way. If I refresh, it gives hello bye, and after 5 seconds it will give me high from timeout after 5 seconds. So the good thing is that, okay, even if I'm writing this set timeout, okay, it's an async action. What is an async action? Basically, it's been declared over here, but it will happen after some amount of time. Okay, I can give you the example. What are the examples of an asynchronous action? It's like clicking on the button and getting a data from an API. Okay, let's say there is a search bar, right? There is a search bar, right? Everyone, you all do online shopping, right? You all order something from let's Blinkit, Zepto, or you all order something from Mintra and all of these things, right? What do you do over there, right? There is a search bar. You can basically search for any product, right? Now the search bar is there, but it depends on you when you want to use it. So it's basically an async action. It's not a synchronous action. Okay, the user will first come and do the search only. Everything was there is an async action only, because for everything there is an API which is basically being called, right? So async action basically is that it is present over there and it will basically happen after some amount of time. Okay, depending on the user. So here also, this log basically this will be logged only after 5 seconds only. Okay, not before 5 seconds. So, but keeping the engine waiting for 5 seconds, it is absolutely not a good thing, right? Rather, what does JavaScript do is JavaScript basically will keep on executing the lines further ahead. Okay, now the question is how does this happen? Okay, the question over here is how does this happen? This basically happens because of so in JavaScript there is something called as a call stack. Okay, okay, there is something called as a call stack, right? And then there is something called as a callback queue, and then there is something called as an event loop. Okay, just be with me, I'll explain all of these things. Okay, let us also take one more example of set timeout. So let's say I will take a set timeout again, and so this basically takes a callback function, two arguments, and it will take a delay. So let me put a delay of 3 seconds over here, and let me just say console.log uh, timeout after 3 seconds. Okay, okay, now over here the question is which will come first. Okay, because firstly I'm writing this timeout, right? And then this is the second line of code. So as I told you, everything happens line by line. Okay, it's a sequential thing, right? Single threaded synchronous language. Everything will happen line by line. Okay, see, JavaScript is not an asynchronous language. You have to always remember this. JavaScript is a single threaded synchronous language. Okay, but what enables async in JavaScript we will discuss right now. How does async in JavaScript actually happen? Okay, it happens because of all of these things: call stack, callback queue, event loop, and all of these things. Okay, so if I save it, let's see what happens. Does it give high from timeout after 5 seconds, or does it give timeout after 3 seconds? So if I refresh this, it gives hello bye. It will give me timeout after 3 seconds, and then it will give me timeout after 5 seconds. Okay, hello bye, timeout after 3 seconds, and then it gives me timeout after what? 5 seconds. Okay, so even though this was written earlier, okay, this comes first. Okay, now let me give you one more example also. So let me just write set timeout over here. Okay, and write take a delay. I'll just take a delay of 0 milliseconds. Okay, 0 milliseconds, that means nothing, right? And if I do a console.log high from 0 seconds, okay, 0 milliseconds means basically nothing, right? 0 milliseconds basically means nothing. So it should ideally first give high from 0 seconds and then it should give hello, right? Because it's 0 milliseconds, it's nothing like that. So if I go over here, if I refresh it, so see it gives hello, bye. So the first thing that is logging it is hello and bye, not high from 0 seconds, right? That means the first line of code that is executing is this one, right? Then the second line of code is executing this one, right? Why? The reason is because this is an async action. Even though it is 0 milliseconds, it will not log 0 milliseconds directly over here. It's an async action. Okay. This part of code is what? It's what? It's an async action. Okay. Asynchronous. So how does this work actually? Okay. So let's pay attention to this part. Okay. So how it is actually working, this async part, how does this actually work? Okay. So the async part basically works in this way. Okay, so there is a call stack. Okay, what is a call stack? Okay, so the call stack basically is a place where all your code is actually pushed. Okay, just imagine it to be like a big box which is multiple, let's say multiple blocks, and all your code is basically is pushed into the call stack. Okay, all your code is basically is pushed into the call stack, and then your code is executed line by line. It's executed line by line. Okay, now whenever JavaScript encounters these type of things, okay, this type of thing like an async action, okay, so when it encounters this type of async action, it will not execute it directly. It will push it into something called as a callback queue. Okay, it will push it into something called as what? A callback queue. Okay, so what will happen? This will go and this will basically, this will be gone from here. Okay, and then let's say there will be a callback queue. Okay, so there is this callback queue, and then okay, let me put it over there only. Okay, so there is a callback queue. So inside, so what will happen? It will basically, there is a callback queue internally. Okay, in the JavaScript engine there is a callback queue, so it will have the first timeout. Okay, so it will have what? It will have the first timeout over here. Okay, it will have the first timeout. Then what will happen? It will see this line console log of hello. Okay, it's not an async action, so it will execute this thing. That's why we get hello over there. Okay, then it will have this part. Okay, it will again say, okay, again there is one set timeout, so it will again go to the callback and say, okay, I have another set timeout also, so it will be a second set timeout. Okay, second set timeout. Okay, then again it will see, okay, again there is a set timeout. It will again not execute this thing. It will again push it over here. Okay, there is a third timeout. Okay, it says, okay, I got a third timeout. Okay, cool. Now, so the first timeout, this was okay. So it got the third timeout. Now it says again there is a line which is console log of by. So it will execute this line. Okay. So now the call stack is empty. See, the call stack initially has all of these part. Okay, all of these part. What does JavaScript do? Whenever it sees an async action like set timeout, it will push it into a callback queue. Callback queue. Let's imagine callback queue is like a small box inside the bigger call stack. Okay, it's like a small box. Okay, obviously it's not inside the call stack, it's outside the call stack. Just imagine like, okay, there is a separate box. Okay, so you basically pick it from the call stack and put it into the callback queue. Okay, got it. So then it executes this line. So this line is executed, it's gone from the call stack queue. Whenever a line is executed, it just vanishes from the call stack queue. Okay, then it sees that, okay, there's another set timeout, it will put it back into the callback queue. Okay, great. It sees another set timeout, it will put the third timeout into this callback queue. So the callback queue now has 3 set timeout. Whenever it is put into the callback, it is gone from the call stack. Just imagine that. So now there is only one line remaining, which is console log by. When this is also executed, again it's gone from the call stack queue. Again it's gone from the call stack. So the call stack is now empty. Now what is the job of event loop? The job of event loop basically is to keep on monitoring the call stack and the callback queue. The job of event loop is to monitor the call stack and the callback queue. Why it monitors the call stack and the callback queue? It will keep on checking if the call stack is empty and if there is something in the callback queue. The event loop will keep on checking whether the call stack is empty and if there is something in the callback queue. So once the call stack is empty, okay, when is the call stack empty? Whenever all of these synchronous line like console log hello, console log bye, all of these things are done, and when all of these asynchronous action are put into the callback queue, right, and then the call stack becomes empty. As I said, once one line of code is executed, then the call stack basically becomes empty. Okay, so once all of them basically are gone from the call stack queue, right? So the event loop checks if the when the call stack is empty, it will check if there is something in the callback queue. Yeah, so there are things in the callback queue. Okay, so this was the first timeout which was 0 seconds. This was the second timeout which was 5 seconds. This was the third timeout which was 3 seconds. Okay, now when it finds okay there are only timeouts with respect to 0 seconds, 5 seconds, 3 seconds, so it will arrange them in order of their delay time. Okay, in order of the delay time. Okay, so it won't arrange them in order of when it was pushed into the callback queue. Okay, in the callback queue, when I have to execute all of these parts, when I have to execute the callback function of the set timeout. Okay, when I have to execute the callback function of the set timeout, that's why it's called as a callback queue, because it has all the callback function. Asynchronous callback function are in this callback queue. That's why it's called as a callback queue. Okay, so it will adjust them. So instead of the third timeout over here, the third timeout basically will come after the first timeout, because the first timeout was 0 seconds, the third is 3 seconds, and the second one was 5 seconds. Okay, so now the event loop knows okay the call stack is empty, but there are three callback functions in the callback queue. So it will start executing them. How will it execute them? In order to execute this one, it will push it back into the call stack. Okay, because this is not like a normal callback function now. Okay, it's like a normal function which has to be executed. Okay, right, it's like a normal function only which has to be executed, right? Yes or no? Right, it's like a normal function which has to be executed, which has a which has one single line. So it will push this function into the call stack, right, one by one. Once this is executed, it will see the event loop again will check if the call stack is empty and if there is more in the callback queue. Yes, there is one more set timeout inside the callback queue. So it will push the callback function of the third timeout this again into the call stack. Okay, that is gone into the call stack, that is executed. Once the again the call stack will be empty, event loop will again check. Okay, now again the call stack is empty. It will again check if there is something in the callback queue. So yes, there is something again in the callback queue. One more callback function that will be again pushed into the call stack. Okay, that line of code will be executed, right? Once it is executed, it's gone from the call stack. So event loop will again check whether there is something in the callback queue and the call stack. If there is nothing, then basically the code is executed. Okay, so this is how it actually working under the hood. Okay, so let me explain this once again. Okay, so if I save it and if we go back over here, we see, okay, let me refresh this. It gives me hello, bye, hi from 0 seconds, and after 3 seconds, and after 5 seconds also. Okay, so how is this working? Okay, how is this working under the hood? Okay, so in JavaScript, as we discussed, JavaScript is what? A single threaded synchronous language. It's not a multi-threaded language. It's not something like that. Okay, but when I say it's a single threaded synchronous language, how does async happen? Asynchronous action happens. Asynchronous action happens in JavaScript because of this call stack, callback queue, and event loop. Okay, there is one more part also. We will discuss that also. It happens because of this call stack, callback queue, and an event loop, right? So what is this callback queue? The callback queue basically will have the callback function of all the async part. Okay, the callback queue will have all the callback function of the async action. Okay, what is the meaning of basically an async action? Async action basically means, let's say if I click on the button, I have to call an API, or I have to click on the button, I have to when I click on the button, I have to execute some piece of code after, let's say, 2-3 seconds. Okay, so this part, right, like set timeout. Okay, this set timeout. So this will log this sentence high from timeout after 5 seconds after 5 seconds. Okay, over here also set timeout, and then this will log this timeout after 3 seconds after 3 seconds. Okay, but there is this console log hello and console log bye also over here. Okay, so how does this work, right? So there is a call stack in JavaScript, right? Every code, all your code is basically pushed into the call stack. Okay, but whenever it encounters something like this, like a set timeout and async part, so it will take out this set timeout this entire part, the callback function along with this delay, and push it into this callback queue. Okay, it creates a queue, a callback queue, right? When it pushes, it takes it from this call stack and puts it into the callback queue, and so this line of code is gone from the call stack. Okay, so now then it executes this line console log of hello. Once this is executed, again it is gone from the call stack. Whichever line is executed, it just goes away from the call stack. Okay. Now again it encounters a set timeout. Since it's an async action, it will again put it into a callback function. It again will put it into a callback queue. Okay. Then again there is a set timeout. Again it will put it into a callback queue. Okay. Because it's an async part. Then again there is what, a console log of buy. Okay. So it will execute this line. So the call stack now is empty because everything is gone. These three set timeout was put into the callback queue, and then this was a large enough code, so everything is executed. So call stack is empty. Now, what is the job of event loop? The event loop is like a loop. It keeps on monitoring the call stack. It keeps on monitoring the callback queue also. Okay, why does it monitor it? It keeps on checking the call stack. So whenever the call stack is empty, so it knows that okay, all the synchronized part is done, right? Now it will go and check whether there is anything in the callback queue. It will check whether there is any callback function inside the callback queue. Okay, so it knows that okay, there are these functions in the callback queue, and in the callback queue, so okay, whenever there is this set timeout, it will be executed in order of their delay. Okay, it will be executed in ascending order of their delay time. Okay, so the first it will be since it is the 0 seconds, so it will execute this line of code. So this callback, how is this executed? In order to execute it, it is pushed back into the call stack. Okay, so from the event loop, okay, event loop will check okay if there is anything in the callback queue. Now this has to be executed. In order to execute this will be pushed back into the call stack. So this callback function will push back into the call stack. It will be executed. Once it is executed, again the call stack is empty. Again the event loop will check whether the call stack is empty or not. If it is empty, it will go and check in the callback queue if there is any callback function inside the callback queue. This job is done by event loop, monitoring both the things. Okay. So now when it sees okay, there is another callback function. Okay. So what it will do, after 3 seconds, it will be basically pushed over here. Okay. So after 3 seconds only it will go. After 3 seconds, it will go into the call stack. Okay, it will go into the call stack, and then it will be executed in the call stack. Okay. Now again the call stack will be empty. Again event loop will check कि call stack में कुछ है कि नहीं. If there is nothing in the call stack, it will check in the callback queue. If there is something in the callback queue, it knows okay there is one thing in the callback queue. Okay, there is another callback function. So after 5 seconds, when 5 seconds is elapsed, when 5 seconds is over, it will push this callback function. It will push this callback function again into the call stack. So this function is executed. Okay, which one? This one. It will push this function into the call stack right after 5 seconds. So this will be executed. Once this is executed, that means everything is executed. Okay, once this is executed, so again event loop will check if there is anything in the call stack. There's nothing in the call stack. If there's anything in the callback queue, there's nothing in the callback queue. That means the code is executed. So this is how it actually works. Okay, this is a very good interview question. It is asked a lot in interviews. Okay, if you're preparing for front-end development, if you're even if you're a beginner or you are a couple of years experience also, 1 year, 2 years also, these questions are asked. Okay, I think one of my friend, he has 3 years of experience. Okay, he also was asked this type of question where it's a single-threaded synchronous language. So how does async basically comes into picture? So you have to explain this part. Okay, obviously it's a theoretical part only. Okay, cool. If you right, it should, actually, I think you should read more about all of these things. Okay, there are multiple articles available on the call stack and the event loop. So you should read these articles. Okay, how does it work under the hood? Okay, cool. Okay, now. Okay. There is one more async part also called as the set interval. Okay, I thought of showing you this as well. Okay, set interval is a very deadly thing. Okay, so let's say 1000, and then if I write a console.log of, let's say, hi, hello. Okay, so if I save this, and then if we go over here, so if you see over here, the moment I refresh it, so after every second it will keep on giving me hi and hello. Okay, after every second. Okay, after every 1 second. But when, okay, when, so now even if you see this over here, okay, this basically would be is also being executed after this hello and bye. Okay, this is executed after this hello and bye and hi from 0 seconds, and then after 1 second it will keep on giving me hi hello, hi hello, hi hello, hi hello, hi hello. Okay, so now you think and you visualize how will basically this work in with the call stack, because you can see the output here also. Okay, so you can see how basically this will work in this thing. Okay, okay, there is one website also where you can basically visualize the event loop and the call stack. Okay, I actually have forgotten visualize. I think the call stack and event loop in JavaScript. Yeah, so this is it. Yeah, JS visualizer. So whatever code you're writing, basically you can put it over here and then you can keep on visualizing it. Okay. So we talked about the call stack event loop. This task queue is nothing but the callback queue itself. Okay. The task queue over here that is written over here, it's the callback queue. So what we can do is, let's say we'll copy this part of the piece of code that we have written, right? And we'll put it over here. We will discuss about the microtask queue also. What is a microtask queue? Okay, so let's see whatever we've done, is it right or not? Okay, so if I run it, so you will be able to visualize it how basically it is working. Okay, so see the event loop. It is evaluate synchronously execute the script as though it were function body, run until the call stack is empty. So I click over here. Okay, so the steps. Okay, so first step in the task queue, if you see there is this function anonymous. What is this anonymous function? It is nothing but this the first set timeout itself. Okay, then if you see it is showing me hello. Okay, console log hello. Okay, on the top right. Okay, because it's executed the console log hello. Okay, the anonymous is the first callback function in the set timeout with the delay 0. Now when I click on the step again, it gives me hello. So let me close this. When I run, click on it again. So if you see, there's one more anonymous function that is being added over here. Obviously it's an arrow function. It's an anonymous function itself. Okay, right. uh, Let me run it again. Okay, set interval is not defined. Let me just get rid of the set interval for now. Edit. Okay, and let's run this again. So anonymous function, right? Hello, and then the anonymous function is just for 5 seconds. Okay, again anonymous function for 3 seconds. Okay, and then if I run it, then it gives me bye. Okay, so now if you see over here, the it's the event loop over here. Okay, let me close this also. Bye. Now when I run it again, okay, step. So if you see this anonymous function is added to the call stack, right? And if you see on the left hand side, it is highlighting this part. Okay, if I could increase the size. So on the left hand side, if you see, it's highlighting this callback function only, and the first anonymous function is added to the call stack. So now when I run it, so if you see it is high from 0 seconds, I'll close it. I'll click on step again. So that anonymous function is deleted from the call stack. Right now there are two anonymous function in the task queue, which is the callback queue only. So when I run it again, okay, so if you see this again, it is added to the call stack. That is what I was talking about, right? Whenever there is callback function is added to the call stack, right? Now when I click on step, so it is executed timeout after 3 seconds. Okay, let me close it. If I execute the step again, that anonymous function is gone. Okay, let me run this step again. Now the third one is added. Now it is also highlighting which one is added. Timeout after 5 seconds. Click on step again. High from timeout after 5 seconds. Let me close this. Let me click the step again. So that is gone and everything is being executed. Okay. So you can view this visualization on this part called as this GS visualizer. Okay. Now let's say if this anonymous function part is confusing, what I can also do is I can create some functions also. So let's say I just write const, or let me just write something called as function. So let me just write something called as 0 seconds. Okay, 0 seconds, function 0 second. Okay, or if you want, I can just create uh, an arrow function itself. So just write const 0 seconds is equal to, and let me delete and put it over here, and over here let me just put it as 0 seconds. Okay, and over here let me create const, how much is it, this is, let's say, 5 seconds equals to, and this basically would be this arrow function. I'm just doing this for the visualization purpose so that it's easy to visualize, right? Yeah, and then let's say there is this const of 3 seconds equals to, and let me remove this part and put it over here, and then let's say this would be 3 seconds, right? I do not need this set interval right now, so I'll just get rid of this set interval part. So now if we go and let me just copy this part, all of this code that we have written right now, and let me put it over here. I think I didn't copy it. Okay, let me click on edit. Yeah, cool. So now let me run it. So the moment I run it, okay, so it takes some time in order to basically evaluate all of the things. Now if you see, if I click on step, it goes to the first part, right? And it, see, it automatically understands, okay, right, okay, that okay, this 0 second is what, it is a callback function. It's an async callback function, so it adds the 0 second. When I click on step, it will console log hello, right, because it's synchronous action. Again I click on step, it adds the 5 seconds into the task queue, right? Again I click on step, it adds 3 seconds into the callback queue, right? I click on step again, it does a console log of by, right? So all the synchronous part is done. Now what it will do, it will keep on adding, it will check the task queue. Okay, so if you see, it says select the oldest task from the task queue, run it until the call stack is empty. Okay, so if I run it, so it has added that function over here. Okay, the 0 second function that is added over here. If you see on the left hand side, it is highlighting that only. If I run it, it will give me high from 0 seconds. Now when I go to the next step, if you see, it has added the 3 seconds callback function, not the 5 second one. The 3 second callback function it has added. Now when I run it again, so it will give me this part also, right? From 3 seconds, and again that callback function is gone. If I click on step again, right, this function is added again. The 5 second function is added. When I click on step, it is executed, right? And then if I click over here again, the function is gone. So this is how basically it works under the hood. Okay, so the task queue is nothing but the callback queue. So you either call it as a callback queue or you call it as a task queue. So some people call it as a callback queue, some people call it as task queue, right? Both of them are one and the same only. There's nothing much of a difference between both of them. Either a callback, you either call it as a callback queue or either call it as a task queue. Okay, cool. Okay, so this was basically the start of the async part. Okay, now let's move ahead. Okay, uh, let me comment all of them now, whatever I've written. Okay, let me comment it till here. Okay, we will come to this part again. Okay, there is one more part. Okay, if you see over here, there is something called as this microtask queue also. So we'll understand what microtask queue also is, right? Just remember this part, JavaScript visualizer, where you can basically visualize all of these async action, right? Cool. Okay, it's a very good thing. So basically will basically it will clear all your doubt. Okay. Okay, now there is one of the most important async activity in JavaScript, okay, or anywhere, okay, related to web development, okay. One of the most important async activity basically is called as getting a data from an API. Okay, not only getting a data from an API, also calling an API. You can get a data from an API. You can post a data onto an API, right? You can update a data to an API. You can delete something using an API. So basically these actions, okay, these actions are also an async action. Okay, these action are also what an async action. Why? Because firstly is you can call the API anytime you want. You can click on the button and you can get the data from an API. As I gave an example of the search bar, you can search for something, right? Right, on Google Maps you basically search for something, right, and then you get your response, you get your data. Sometimes it says that okay, this is not available, that is not available. So all of this basically is what is happening. There is a database which has the data, right? You basically call an API which is given to you by the backend team, right? Or you have created an API, right? So you will basically use that API to get the data from the database, right? You or basically you can post the data into a database using basically that API, right? So this is an async action. This can happen anytime, right? This can happen anytime. So that's why it's called as an async action, because it does not go sync by sync, right? It depends on the user. Whenever the user wants to do it, so it's basically uh, the code is written, okay, or it's being based the but it's being executed sometime else. Okay, I've done it now, but I'm going to I've seen it now, but this can be executed whenever it is being called. That is an async action. Okay, cool. Okay, so let's see now what is getting a data from an API. So whenever I basically call an API, JavaScript basically brings in a concept of something called as promise. Okay, promise. Okay, so whenever basically I call an API, JavaScript basically brings in a concept called as promise. Now, what actually is a promise? Okay, so promise. Okay, let's see an example. Then you will understand what promise actually is. So now to create a promise, I can simply create a promise. I can start const promise equals to new promise. So this new is basically a constructor. Okay. Now this promise basically, if you read about it, it says it's a callback used to initialize the promise. Okay. This new promise, if you see, it's an executor, basically means it's nothing but a function which will be executed, which does not need to be called monetarily. Okay. And in the previous session, in the last session on Sunday, we discussed about what is a callback function, right? When you pass a function inside a function, the function that is passed is called as a callback function. Okay. When you pass a function inside a function, the function that is passed, let's say there is function x and there is function y. Okay, there is x and y. If you pass y into x, okay, if you pass y into x, then y is basically the callback function. Okay, so here also it says it's an executor, basically it's a callback function. Okay, it will take two values, one is resolve and one is reject. Okay, and it says that it's a callback function used to initialize the promise. This callback is passed with two arguments: a resolve callback used to resolve the promise with a value and a result of the result of or the result of another promise, and a reject callback used to reject the promise with a provided reason or an error. Okay, and it says let's create a new promise. So to resolve a promise or reject a promise. Okay, what is resolve a promise or reject a promise? Okay, so let's understand this part. So let's say I have to get a data from an API. When I have to get a data from an API, right? When I have to get a data from an API, there are either two possibilities. I can either get a data from an API or I can either get some error. Okay, it's not that every time. It's not that you will never get any error. Okay, most of the times, okay, if everything is working fine, you will basically get the success response and you'll get the response. But sometimes you can get an error also. Let's say if the internet is too slow, right? Or let's say if there is a lot of burden on the server, right? Then you can get some error. Or let's say if it is being redirected to somewhere else, you get an error. Or let's say if the user is not authenticated, if it requires some authentication, then you might get an error, right? Let's say for example, you're trying to log in, right? And you enter the incorrect username and password. Obviously, you always see an error which says invalid username and password. Why? Because you are getting that error basically from the API itself. When you call an API, right? You call an API that okay, this is my user with this username and this password. It will basically check into the database, right? It will check into the database. If that username and password is not available in the database, if the combination is not available in the database, right? It will give an error. Okay, that this user is not registered. I do not have any user like this. So you'll get an error, invalid username or password, right? So there are possibilities you'll get an error. You possibilities will get basically the success also. So whenever there is an error, we say it's a rejected promise. Okay. Whenever it is success, we say it's basically being resolved. Okay. So basically, when I get a data from an API, a success response, so I'll say, okay, it is resolved. When I get an error, it says it's been basically being rejected also. Okay. So rejection also can happen when let's say the endpoint is incorrect also. Okay, that time also the rejection basically happens whenever the endpoint is incorrect. That is actually the best example of rejection. Okay, so let's say it takes a callback function over here. Okay, it takes a callback function, and in the callback function it takes two parameters. One is the resolve, and one is reject. Okay, resolve and one is reject. Okay, so what I can do is in the resolve, I can some directly write, let's say resolve, and I can just write over here as console.log. Okay. In the resolve, I can simply just pass a value, which would just be, let's say, uh, done. Okay. And if I save it, okay, if I save it, and then let's say if I go back over here, let me refresh this. Okay. So this promise over here is basically being created. Okay, this promise over here is basically being created, but in order to get the value of the promise, what I'll have to do is I'll have to just write promise dot then. Okay, promise dot then, and I'll just have to write, let's say it will take the response, and we'll just do a console.log of the response. So if I save it over here, so if you see, I basically get done. Okay, what I'm basically getting a done over here. Okay, so I can also either reject a promise also. So instead of resolve, let's say I can just write reject, and I can just write done also. Okay, but now if you say, if I refresh it, it does not. It says uncaught in promise done. Okay, whenever I'm trying to reject a promise, I have to use a catch also. Okay, and let's say I'll pass an error. I'll just write console.log of the error. So I'll get done over here. Okay, so there are two parts. Okay, there is resolve and one there is reject. So let's say if I resolve a promise directly over here and write resolved and save it, so I'm only going to get resolved, right? Out of them, only one is going to be executed. It is going to be either resolved or it is going to be either rejected. Okay, both of them are never going to be executed simultaneously. Okay. Okay, so both of them would be never executed simultaneously. It will basically be executed only. It will either a promise is resolved or either a promise is rejected, right? So whichever it encounters first, that basically would be done. Okay, that basically would be done. So now what is this dot then and dot catch? So whenever a promise is created, whenever basically a promise is created, so let's say if I do a console log of promise also, let's see what does this give. If I do a console log of the promise, okay, so let me just close it, comment this one out. I know console log of promise. So if you see what is this promise, okay, let's talk about what the promise actually is. Okay, I've created a promise. Okay, I've created a promise. So, and let's say if I do not do anything over here, okay, and let me refresh this. So it gives promise. Okay, and so let's say nothing is there over here in this promise for now. Okay, I've created a promise directly. Okay, I've created a promise. Okay, by using this constructor new promise, and then there is resolve and reject. It takes two parameters. Let's say I'm not even passing any parameter also. Okay, the moment I create a promise, okay, so the question was what is actually a promise. So if you see over here, promise, what is it giving me? It is giving me an object. Okay, promise is giving me an object. Okay, with what, with two things. One is the state and basically the result also. Okay, so basically promise is an object which will basically have the state of the promise. Okay, and the result also. Okay, basically the value. Okay, whenever the promise is the what are the states of the promise? State of the promise are pending. Okay, resolved. Okay, pending, fulfilled, rejected, and settled. Okay, Promise has 4 states. One is pending, one is fulfilled, one is rejected, and the other is settled. Okay. Initially, every promise is in the pending state like this. So when the promise is created, it is in the pending state. Okay. Whenever promise is created, it is what? It is basically in the pending state only. Now then, let's see if I pass a resolve or if I pass a reject, right? And then if I want to resolve the promise, so if I do a resolve, and then if I do a done over here, and if I log it, okay, the promise. Now if you see, the state has changed to fulfilled. The promise is changed to fulfilled, and what is the result? The result is done. Okay. Or if I write over here, promise is fulfilled, so it will give me promises fulfilled. Okay. The result is promises fulfilled. The state has changed to fulfilled. Okay. Let's say if I rejected, instead of resolve, if I write reject over here, and I say promise rejected over here, and if I save it, so if you see over here, okay, the if I do this log, it says the state is rejected and the result is promise rejected. Okay. So these are 3 states. What is the settled state? When the promise is fulfilled or the promise is rejected, we say the promise is settled. Okay. When over here you won't see settled something like this. Okay. But theoretically there is another state called as settled also. So let's say if someone asks you what is a settled promise, that means if a promise is either fulfilled or the promise is rejected, that means the promise is settled. Basically you're basically getting the output of the promise, either it is rejected or either it is fulfilled. So that means the promise is settled. So majorly there are 3 states. One is pending state. Every promise created is in a pending state. Okay. Promise is nothing but an object, okay, which has state and the result of the promise. Okay. Which has the current state of the promise and the result of the promise also. So initially every promise is in the pending state only. Okay. Initially every promise is where in the pending state only. Okay. Sorry. When the promise is fulfilled, okay, you will get the value, whatever is the result. Okay. When the promise is rejected, you will basically get another value. Resolve basically means fulfilled. Okay. And reject is the rejected. Okay. If the promise is fulfilled or the promise is rejected, we say that the promise is settled. So this is what nothing but a promise actually is. Okay. Now, if I want to log this value, okay, if I want to log this value, okay, that the promise is fulfilled or promise is rejected, then what I have to do is, then I have to use something called as the settler functions. Okay. Okay. So on a promise, I can apply these methods called as then, catch, and finally. Then basically means then. When is then used for? So let's say now this basically, okay, or let's say when a promise is resolved, okay, let's say I want to execute this value. I want to say that, okay, the promise is basically being fulfilled. Okay. I want to log this value, or I want to pass this value somewhere. I want to use this value. Okay. Let's say the promise is resolved, let's say, and with some ID also, let's say with ID 1 2 3 4, and let's say I want to use this value. Okay. I want to use this value somewhere in my code. So how will I get this value? In order to get this value, we basically use a method called as then. So the then basically is used basically to execute, or basically the then basically used to get the value basically when the promise is basically being resolved. The then basically is used to get the value when the promise is actually resolved. Okay. So now at promise.then, then basically takes a callback function. Okay. What does it take in the callback function? It will take a value. Okay. What is this value? The value is this value, which is written inside this resolve. Okay. This is the value. The value is this value which is written inside this resolve. That's why when I do a console.log of value over here, when I do a console log of value over here, so if you see, I get promises fulfilled with ID 1 2 3 4. Okay. And I can also do this console log of promise also over here. So it will give me promises fulfilled, and then there is this result. So if I want to get this result, okay, if I want to get the result of this resolved promise, I want to get the result of the resolved promise, I have to use the then method onto the promise. Okay. I have to use the then method. Then basically means if the promise is resolved, then what? Okay. If the promise is resolved, then what? Then it will take a callback function. Why it takes a callback function? Because it wants a value over here. Okay, it wants a value. If I simply write console log of value, how will it know what value is? If I simply write a console log of value, it does not know what value is. So it takes a callback function with a parameter. This parameter can write anything. You can write value, you can write response. Generally, we just write something as response. Okay, res. So we understand, okay, it's a response. Okay, understand that is nothing but a response in itself. So we'll take this response, right, and we'll log the response. What is this response? This is this response. Whenever the promise is fulfilled, whatever is the value written inside this resolve. Okay, I'm saying resolve the promise with this value. Resolve the promise with this value or with this response. So this value or this response basically is passed over here in this parameter. Right? But let's say I'm rejecting the promise. Okay, reject. I say promise is rejected with with error code. Let's say something as 404. Promise is rejected with error code 404. Okay. Now if I save this, if I see over here it says promise rejected and the value is there, but the value is not logged. Okay, so the then basically will never log the value of this rejected promise. Okay, then never logs the value of this rejected promise. Now promise is not resolved. See, as I told you, out of both of them only one is executed. If reject is executed, anything after the reject, any resolve or anything, it is rejected only. Any reject of anything after the reject, let's say if there is a resolve after reject, it is ignored. Even we saw the same thing with resolve also. Any reject after the resolve, that was also rejected. Okay, so now over here, if you see promise rejected with error code 404, the result is over here, but I'm not able to see, and it says uncaught in promise is rejected. Uncaught basically means I didn't catch the error. Okay, uncaught basically means it's uncaught. I didn't catch the error. So that's why I can use catch. So I can use it after the then. So I just write dot catch, and then okay, this gives me the error. So I can just write over here console.log of the error. Now it's not necessary that you write this same variable. Okay, this is just a parameter. You can write error also, right? Or you can write value also. So if I save it now, so if we see it says promise, the status is rejected, right? And promise rejected with error code 404. So if anytime someone asks you what promise is, you have to say this thing. Promise is nothing but an object which basically has the state of the promise, okay, which is either pending, fulfilled, rejected, right? And it also has the result of the promise. Okay, when it is rejected, whatever is the result, when it is a result, whatever is the result, and then you basically write a line of code like this. Okay. In this case, if you see the promise directly being rejected, so obviously there is no need for this then also. So what happens if I remove this then? Will it work? That is the question. Okay. So if I save this now, okay. So if I go over here, so if you see, it is still working. Okay. So it is not necessary that the then will come after the catch only. So the catch will come after then only. Okay. It's not necessary that the catch will come after then only. The catch can come before the then also. Okay. The catch can come where before the then also the catch can come, because it can directly be applied on the promise directly itself. Promise.catch. I want to just catch this error. Okay. Let's say if I remove this from here, the resolve, and put it over here, now what will happen? Okay, let's see. Okay, I'm resolving and I'm using catch. So if I go over here, okay, it says promise is fulfilled, obviously because I'm logging this promise, but I'm not able to get any value. So can I do this thing after the catch? Can I apply the then? Let's see this also. So response, and I can just write console.log of the response. Okay, and if I save it, okay, so I'm applying the then after the catch. Now I'm just doing the reverse part. So if you see, it is working in this way also, right? Even though the promise is resolved, I'm using catch, and after the catch, I'm using then. So what does it do? It will do promise.catch. Okay, there is no error to be caught, so it will not catch obviously any error. It will go to the then and says, okay, there is something in the then, so it will just do it in this way. Okay. Now let's understand this basically part with the visualizer also. So let me just write some piece of code over here. So let's just write console.log of hello. Okay, hello promise. Okay, and then let's say I write this also. After this promise, I write console.log of by promise. some key I have pressed. I do not know what it is, because of which it is blinking in this way. Boom, boom, boom. Okay. Yeah, thanks. Nice to have you, sir. Nice to have you as well. Okay. So now when I write it in this way, console log hello promise, and then console log, and then let's say I just remove this part and console log of bye promise. So what do you think? What is going to happen? Okay. Okay. Because then there is this catch and then also. So let me save this. And if you go over here, so if I refresh this, what does it give me? It gives me hello promise, bye promise, and then it gives me promises fulfilled with ID 1, 2, 3, 4. Okay. So it just gives me promises fulfilled with ID 1, 2, 3, and then 4. Okay. Okay. Let's say if I have a console log over here also, console.log of first line in promise. Okay. And then after, let's say, this reject, I have console.log second login promise. We have to understand how this will also work. Okay. Because it will, obviously we know it will give console log of promise. Then what will it give? It will give first line in promise, or will it give by promise? Okay. This is important because it should give console log hello prom. If so, see, if I go by my thinking, I will think it should give me hello promise, then console log by promise, and then first line in promise, and then executed with this error, and then second line in promise, something like this. So if I run the code, so if you see how does it work, it doesn't work in that way. Okay, so if you see it, yes, hello promise. Okay, now it has to see, this promise, whenever I write this thing new promise. Okay, you have to understand that this promise is executed. It's not like any other function. Okay, it's not that when I call it only, then only it is executed. Okay, it's not like that. It will be executed directly. Okay, this promise is executed. So it gives me this console log of, okay, first line in promise, then it gives console log second line in promise, then it gives me by promise. Okay, and then it gives me whenever the promise is rejected or fulfilled, whatever it is happening, it gives me over here. Okay, so see, this, it works in this way. Okay, let me comment this part of code and let's see. So if I run this code, still what is happening? As I told you, it does not require any calling or anything like that. Okay, whenever the new constructor is created, it keeps on executing. It's just starting to execute. Okay, so if you see how it is also written, creates a new promise. Callback used to initialize the promise. Okay, callback used to what? Initialize the promise, and this callback is passed to arguments. A resolve callback used to resolve the promise of the value or the error of another promise, and reject callback used to reject the promise of the provided reason or error, whatever it is. Okay, so now with this part, it's not like a regular function which needs to be executed. It's just it is executed. Okay, so it will give you hello promise, and then it executes this line, first line in promise, then it executes the second line in promise. Okay, and then it gives this console log of by, and then if I, let's say, if I have this part over here, okay, then it gives me the result, which is promise is fulfilled with ID 1, 2, 3, 4. Okay, now how is this being executed? Okay, how this promise is also being executed. Okay, over here also I can basically pass a set timeout also. So for example, I can just create a set timeout. Can create a set timeout, and inside the set timeout, basically I can just resolve this promise. Let's say after 2 seconds. Okay, so if I save it and if I go over here, if I refresh this, so promise is rejected with error code. Yeah. Okay. So now if you see, okay, over here, if I refresh this, it just gives me promise rejected with error code 404, because what I'm let me comment this part. obviously because I've applied a set timeout over here, so rejection is happening. So if I refresh this, it will basically give me promises fulfilled with ID 1, 2, 3, 4. Okay, after whatever seconds it is being given. Okay, but so I was just trying to show you that this we can write it in this way also. Right now, let me write it in this way, and let's see this and let's understand how is this also working. Okay, so we saw about this call stack, callback queue, and the event loop. Okay, there is one more part to this part. There is one more part to this thing. Okay, there is one more thing which basically is called as uh, the microtask queue. Okay, so see, whenever there is something called something like the set timeout and something like that, it basically goes into the callback queue. But whenever there is something called as a promise, whenever a promise is created, the promise does not go into the task queue, but it goes into something called as a micro task queue. Okay, where does the promise go? The promise goes into the micro task queue. Everything is same. Each and everything is same, except that the promise basically will go where into it goes into the micro task queue. Okay, so it's this the function is the same way. There is a call stack. Okay, there is a micro task queue, there is an event loop. Just imagine three things: call stack, event loop, and then the micro task queue. Okay, so in the call stack, everything goes line by line. Okay, it will just see this console log, it will execute this console log. Okay, now when it sees that there is a promise, it will put this promise, okay, the callback function of this promise inside the micro task queue. Okay, it will put the callback function of this promise inside this micro task queue. Basically, it will execute this. It will execute. See, we said it will execute it. So when it executes it, it will execute this line console log first line promise. It will execute this line also console log second line promise, and then it will put this part inside the micro task queue. Okay, the callback of the resolve or the result, put it in the callback micro task queue. Okay, then execute this line also. Okay, so once every line is executed from the call stack, okay, the event loop will check if the call stack is empty and if there is something in the micro task queue also. Okay, event loop will check that also. Okay, so there is call stack, there is micro task queue, and there is event loop. So whenever one line is executed in the call stack, it just goes away from the call stack. Okay, and then the event loop will check whether there is something remaining in the call stack or not. If the call stack is empty, what will the event loop do then? It will basically check if there is something in the micro task queue or not. Okay, so if there is anything in the micro task queue, it will put it in the call stack, and then that line of code is also executed. Okay, so this is how basically it actually works under the hood. So let's just see this. Okay, let me just copy this code. Okay, and let us put it into this JS ka visualizer. Let me edit this part and put it over here. Okay, and now let me run the code. Okay, so it is evaluating. Let me just click on the step. So the first thing it just gives console log hello promise. Okay, now click on step again. Now if you see, it has added this anonymous function into this call stack. Okay, this function directly added into the call stack. Just pay attention. Okay, I click on step, it gives me first line and promise. When I click, it gives me second line and promise. Now again, when I click on step, okay, that function is gone. Okay, I click on step, it gives me by promise. Okay, now when I click on step again, if you see, it is added into the microtask queue. Okay, because it came and it is executing this line. Okay, so this function, this callback function is there in the then, that is added to the microtask queue. The callback function which is there in the then, it is added to the microtask queue. And when I click on the step, okay, it is added to the call stack, and then it gives me promise fulfilled with ID 1, 2, 3, 4. Okay, let me explain this once again. Okay, so what I'm going to do is over here, I'm just creating a function promise fulfilled, function promise fulfilled. Okay, it will take a value, and I'll just do a console log of value. Okay, and over here in place of this then, I will just write this method, which is called as promise fulfilled. Okay, that's it. Okay, so basically this method basically will be added into the call stack in the microtask queue. Okay, this method will be added into where? Into the microtask queue. Okay, so let me copy this code again and let me put it over here. Let me just edit this and let me put it over here. Okay, now let me run the code. So if you see, the moment I run the code, when I click on step, it gives me hello promise. When I click on step again, okay, it has added this anonymous function. Okay, this entire, if you see this one, it is added where? In the call stack. Okay, it is adding this to the call stack. When I refresh this, it executes this function. Okay, first is first line in promise. Then again, when it click on, it didn't execute this thing resolve. Okay, because it knows what now. The resolve or reject is nothing but it's creating a promise. Okay, resolve or reject is nothing but creating a promise. And now if you have to, you understand this part that when I write this, when I create a promise, it's not like a function call where I have to call it. Okay, it is executed directly. It's basically an executor function which is going to be executed directly. Okay, you have to understand this part. The promise is not executed because of this line, because it has not come here. It is still not here. So promise is not executed because of this line. Okay, only the resolve and reject will be executed because of this line of code. But apart from that, whatever is written in promise, that will be executed. Understand this part. See, if this promise, okay, it is basically being executed directly over here only. Okay, so it is just it's being just executed, and we saw this also. Even when I had commented this line, it was still giving me first line in promise and second line in promise also. Okay, so it's not being executed because of this part. Okay, this will be executed. This is how promise actually works. This new promise constructor is just an executor function. It will execute it first line in promise, second line in promise. Okay, and now when I click on step again, so this anonymous function is gone and removed from the call stack. But now when I click on step again, it gives me by. Okay, but there is this promise.catch and .then also. Now when I click on this thing, so now if you see what is added to the microtask queue, this promise fulfilled. This method, okay, this being added to what? To the call stack, to the microtask queue. Okay, it is being added to the microtask queue. And then when I run it again, okay, so now it sees, okay, the event loop basically checks if when the call stack was empty. Okay, it knew that the call stack is empty, so it will check if there is anything in the microtask queue. Okay, if it is there, if there is nothing in the microtask, if there is something in the microtask queue, it is added to the call stack. And then when I click on step again, it executes this thing, promise fulfilled with ID 1234. And when I click on step, it's gone. Okay, so this is how basically it is actually working. Okay, the type microtask queue. Okay, so any promise which is created is basically added to the microtask queue. And which callback function is added into the microtask queue? The callback function of the then, or basically of the reject. Okay, so let me just edit this part now, and let me just comment out this resolve, and let me just take the reject one. Okay, and over here let me just create a function. Let me just create a function. Instead of promise fulfilled, let it be promise rejected. So I'm just creating it directly over here, promise rejected. And over here, instead of this error and all the things, I will just pass the method which would be promise rejected. Let me save this. No, I don't want to save it. Okay, so if I run it, okay, no. Yeah. So if I run it now, so click on step, hello promise, right? Anonymous function is again added. It is being executed first line promise. Now if you see, it has added this thing. Okay, reject and promise rejected into where? The microtask queue. Okay, second login promise. Okay, it says by step, and it has added the promise rejected into the call stack. When I click again, it says promise rejected with status code error code 404. And it's gone. Okay, and then this. Okay, so this is how basically it is actually working under the hood. Okay, okay. Now there is also a question. Okay, The question would be, what if there is, now there are two queues. One is a task queue and one is a microtask queue. What if there is a callback function in the task queue, and what if there is a callback function in the microtask queue also? Okay. What is there is a callback function in the task queue? What if there is a callback function in the microtask queue also? So what will be executed? Which is given the priority? Okay, that should be a question. Yes or no? Okay. So what we'll do is, it's almost 1.5 hour. We'll take a break of 10 minutes, right? And we'll just come back in. Okay, we'll take a break of 10 minutes, and we'll just come back in 10 minutes, right? And then we'll continue after that. Okay, so I'll just write over your timer. So after that, we'll again take a stretch of 1.5 hour. So just um take a break. Okay, if you want to eat something, and just come back in 10 minutes, because from 11:30 we'll basically extend it to at least 1 o'clock, right? So you'll have good amount of time for yourself. Okay. Hello, everyone. Hello, everyone. Sorry about that. Basically, I'm using the phone in order to check the chat, to see the chats and see the questions that are coming. Okay, cool. So where were we? Okay, over here we were over here. Okay, about the task queue and the microtask queue. Okay, so how does it actually work? Okay, so now let's say let me write a combination of this codes. Okay, so what I'll do is I'll just take these questions from here. I'll just take this. Let's say this set timeout this 0 from here and put it somewhere over here. Okay, and let's say then I'll also take this set timeout car 5 seconds and put it over here. So now this code has a combination of two things. Okay, this code has what a combination of two things. It has the console log hello promise and then set timeout of 0 seconds, then a set timeout of 5 seconds, and then a promise resolved. So what I'm going to do is I'm just going to change things over here. Instead of this dot then over here I'll just write it in the way which we generally write, dot catch, and then create a method called as what, promise rejected, right? Since there is no method as promise rejected, I will use this and create a method as promise rejected, and then the value. Okay, see, the variable can be anything. You either write error, you write value, or anything else. Doesn't make a lot of difference. Okay, so now if we go back and if we check over here, okay, if I refresh this, so if you see over here, I get this hello promise. Okay, first line and promise, second by promise is fulfilled. Okay, now let's visualize this part. Okay, so if you see, this set timer basically came over here, from 0 seconds also came over here. Okay, it didn't come after this second login promise or before this part. Okay, let's just visualize this part of code. Okay, instead of me talking, let me just copy this line, copy. Let me put it away. Let me just edit this part. Let me run this code. Okay, so how is this working? So let me just get rid of this comments. Okay, so yeah, so if you see over here, we have these functions, right? So let's run the piece of code. So when I run it, okay, I click on step. Okay, when I click on step, I get hello promise. Great. Hello, I got hello promise. When I click on step again, see, the first thing that is added to the task is this const 0 seconds. Okay, it knows. Okay, it's being added where? It's added to the task because it knows that, because it has executed set timeout, so it knows it's going to go into the task queue. That is the callback queue. Now I click on again, it puts 5 seconds in the callback queue, task queue. Click on step again. So now what is it doing? It is it has executed this part, right? I told you the promise is executed directly. Okay, it's not it does not require like a function call or something like that. So it puts an anonymous function in the callback. It's an anonymous function, it's not a named function expression. Adds an anonymous function. The good part is that it's highlighting, so you are able to see it also. Now the anonymous function has to be executed, so it gives first line in promise. Okay, now it's, see, when it comes to the second line resolve, it adds the promise fulfilled into the microtask queue. Okay, because there is promise dot then, right? So it adds the method. It knows, okay, when the promise has to be resolved. Okay, when the promise has to be resolved, it is checking whether there is any method present in the then. Then is again then basically again takes a callback. Okay, so the then is a method. Okay, then is a method which has a callback which will be executed only when the promise is resolved. Then is a method which has a callback which will be executed only when the promise is resolved. Okay, Cool. Resolve or fulfilled. Okay, so it adds this the promise fulfilled into the microtask queue. What is the anonymous function? It's still this function because console log second promise is remaining. So if I click second promise, when I click again, so anonymous function is gone. Okay, now comes the time of truth. Now the task queue has two methods, 0 seconds and 5 seconds. Okay, the microtask queue has promise fulfilled. Okay, ideally if you see what should be executed, the 0 second should be executed, right? And the 5 seconds should be executed, then microtask queue should be executed. But if I run the code over here, this is going to give me by promise. Okay, now the event loop knows that the call stack is empty. Okay, when I click over here on the step, it knows that the call stack is empty. So now it has to decide which one to ask, task queue or the microtask queue. So by default, microtask queue is always given high priority over the task queue, even though these two callback functions, 0 second and 5 second, were added before the promise fulfilled. Okay, 0 second and 5 second were added in the task queue before promise fulfilled in the microtask queue. But what does the event loop do? Now the event loop has three things. It has to check the call stack, it has to check the task queue, it has to check the microtask queue also. Okay, now when I click over here, it gives promise fulfilled with ID 1, 2, 3, 4. So the event loop now has three things. It has a call stack, it has the microtask queue, it has a task queue also. So when the event loop checks the call stack, when the call stack is empty, it will go and first check whether there is something in the microtask queue or not. Okay, it will go and first check whether there is something in the microtask queue or not. If there is something in the microtask queue, it will execute that callback function. It will put that callback function into the call stack, just like this promise fulfilled. It was earlier in the microtask queue, now it has come into the call stack. So if there is nothing into the microtask, if there is something in the microtask queue, it is that into the into the call stack, and then it will be executed, right? Okay, when I click on step, so that is gone. Now if you see, there's nothing in the microtask queue, call stack is again empty. Now what the event loop will again do, when I click on step, okay, now it will again check if there is something in the microtask queue or not. If there is nothing in the microtask queue, then it will go into the task queue and start executing the task queue. So the 0 second method was there, right? Now it is executed. Another 5 second method will come, and that will be executed. Okay. So this is how basically event loop actually works. Okay. So when it comes to when there are method in the task and when there is method in the microtask queue also, it will basically give priority to the microtask queue, because microtask queue has things like promise. Okay, getting the data from an API. Obviously, that is a very important task. Right, getting the data from an API is very important task. Okay, even if there was a set time out of 0 seconds. Okay, even if there is a set time of 0 seconds, does not matter till the time there is a task inside the microtask queue. So there is something in the microtask queue that will be executed before the task queue. Okay, so if given there is something, if given there is a callback queue in the task queue, and there is a callback in the and there is a if there is a callback in the task queue and there is a callback in the microtask queue. Okay, whatever is a callback in the microtask queue will be executed before the callback in the task queue. Okay, whatever is a callback in the microtask queue will be executed before the callback in the task queue. So the callback in the microtask queue are given priority. Why? Because these are API calls. Okay, generally you have API calls over there. Okay, you have API calls, so obviously it will be given higher priority over the task queue. Okay, so this is how async JavaScript actually works under the hood, because of call stack, event loop, task queue, and microtask queue. There are a lot of things to this. Okay, if you want to learn more and want to learn more deeply, all of these things, do join our FSRNL, okay, full stack batch. So even if you just search for FSRNL Geeks for Geeks, okay, so you'll see this thing, full stack development with React, FSRNL, okay, FSRNL, full stack with React and Node. So if you just go through this course, okay, you can basically enroll in this course. A very, 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 very good course. So if you see basic to advanced, 14 weeks. 14 weeks basically means it's a 3.5 months course. Very good, very good. 3.5 months. See, your boy is here. Okay. and we have got good reviews. Okay, and these are not, to be honest, these are not paid reviews. These are reviews given to us by students on their own, or students on their own. Okay, and these are good plus points of having this course, where there is this 70 plus of live lectures, and then there are 60 hours of recorded content as well. So you get live sessions and you get recorded content as well. Recorded content on everything, starting from HTML, CSS, JavaScript, React.js, Node.js, MongoDB, right? Redux also, right? And there are C300 plus practice questions, where practice questions basically has MCQs, and it also has other questions also, right? And there are interview questions also. There are during the week also, there are every day there is every day there are sessions where the teaching assistant will come and help you, right? There are contests, there are weekly assignments also. So it's a very, honestly, it's a very very good course. So if you see, there is 24/7 doubt support, and you will get these doubt supports as well. Obviously, you get a certificate from Geeks for Geeks. There's no one in the tech field who does not know what Geeks for Geeks is. Everyone knows in the tech field what Geeks for Geeks is, right? For me also, when I was working at Geeks for Geeks and when I switched to another company, having the title of Geeks for Geeks created a lot of edge for me, right? And then there are instructors as well, right? So instructors basically change, right? There's me, there is Sumit, and there are many other instructors also, and everyone is very very good. Okay, it's not that people are not good. And see, there are these there are these students placed, right? We have a lot of students placed everywhere, a lot of at a lot of different places. Then there are courses also. If you go to courses, so let's say we go to this full stack development courses, okay, or let's say DSA to development, I think, or we go to all courses. I think let's go to all courses. So if you go over here and if you select, let's say, development and testing, if you go to the courses part, you select development and testing, right? So you have all of the courses. There is this full stack. This is the live session, right? This is my course, React.js course, right? You can go through this course beginning to end. There is a complete JavaScript course as well. This has everything. Okay, if you take this JavaScript course, there's no need to go anywhere. This has each and everything covered in JavaScript. Maybe uh, everything which is required. So this is not only for beginners. This is for someone who has experienced 1 to 2 year also can take this course and basically improve their JavaScript knowledge. Is this important for React Native? Yes. See, we are learning JavaScript. Okay, everything in JavaScript is important for React Native. Okay, because React Native obviously is the foundation is nothing but JavaScript itself. Okay, enough of promotion. Let's go back. Okay, so we covered. Okay, now with this promises, there is also another part called as async await. Okay, so promise basically can be written in a different way also, called as async await also. Okay, so okay, instead of but before async await, okay, let's try to get a data from an API. Okay, how do I get a data from an API? By using this dot then and dot catch. I've created promise over here. There are many things in promise. Obviously, I obviously cannot cover everything, but you can basically go and um, you basically can find a lot of articles and read them. Okay, so let's say I'm writing over here what, let's say fetch data from API. How do we basically fetch a data from an API? So how do you get a data? Let's say we will use this something called as dummy JSON. Okay, you just search for dummy JSON API, you will find this thing dummy JSON. Okay, and there are a lot of places where you can basically get free data also. We're just going to go through the test data. So just click on the read docs. Okay, and yeah, so I'll click on products and I click on get all products. Okay, so this is the endpoint that I have to use. Okay, so let me just copy this. So if I have to get a data from an API, I will simply write fetch. I'll use the fetch API, and then I will just paste it over here. Okay, I'm just going to use the fetch API, and I'm just going to put the API over here. Okay, so if I save it, let's see what happens. Is there anything in the console or not? I'm just trying to visualize. There's nothing in the console. So this is to fetch the data from an API. Okay, fetch API is used to fetch data from this API. Okay, what will this API give me? Okay, so if you see over here in the product JSON, if I click on show output, it will give me this data. It will be an object which will have products as a key, and then it will have an array. Okay. Now, how do I get this data? So whenever I use fetch in order to get the data, I have to see this fetch basically creates a promise. What does fetch do? It creates a promise. We learned promise just now. So fetch will create a promise where basically this promise basically can be fulfilled or it can be rejected. Okay, initially it's in a pending state and can be fulfilled and rejected. So let's say if it is fulfilled, if I'm getting the data, right? In order to get the data, if the promise is fulfilled, if I'm getting the data, I have to use a dot then callback. Okay, I have to use the dot then callback. Okay, if I'm getting the data. So what I can do is over here, okay, don't know what in the world I've pressed over here. So I can just use a variable called as, let's say, response that I'm getting, right? And then I can just do console.log of the response. Okay, so if I save it, if I go over here, so if you see when if I refresh it, I'm getting the response. What I'm getting, I'm actually not getting the entire data. Okay, so this is nothing again but a promise. Okay, this is nothing but again it's again creating a promise. So basically, when I fetch a data, when I use the fetch API to get a data from, when I use the fetch API to get a data from this API, from this endpoint, okay, dummy.json.com/products, and then when I use then this response that I'm getting, this response again is nothing but it's giving me what? It's giving me nothing but a promise itself. Okay, so the way this response is written over here, this is again nothing but a promise. Okay, this is again nothing but what? It's a promise. Okay, so what I'm going to do is, okay, whenever I get a data from fetch, okay, I have to first convert this into a JSON. So I'll just do response.json. Okay, again gives a promise. Okay, so this then method will again return a promise. So whenever a promise is returned, okay, again whenever a promise is returned, if the promise is settled, then what should happen? Then again I will again use a then, and let's say then I'll say value, and I'll just write console.log of the value. Okay, so let me save it. So if I save it, if I go here, so now if I refresh it, if you see it, I get this thing. Okay, I get the value. Okay, so what have I done over here? See, whenever I'm using the fetch, because fetch will never convert the response into JSON, and I always want the response to be into form of JSON. Okay, so I'm going to fetch the data from this API. If the fetching is successful, okay, so because basically fetch will create a promise. Whenever you have to get a data from an API, it is a promise only. It automatically creates a promise. So when the promise is fulfilled, then what should happen? So when the promise is fulfilled, then this callback would be executed. When the promise is happening, this callback would be what? It will be executed. Now, whenever I'm getting a data from, whenever I'm using fetch and getting data from an API, it will basically again create a promise, because this it will create a promise, right? And what I'm going to do is I'm just going to convert the response into JSON, okay, in a JSON format. This will create a promise. Now, since this is creating a promise, this promise will again be settled or rejected, or be fulfilled or rejected. So the promise is fulfilled, then what I have to do? Then again I have to log the data. Let's say if the promise is rejected, then what I'll do is I'll just do a dot catch, and let's say error, and then I'll just do console.log of the error. Okay, let's fail the promise. How do I fail the promise? I'll just change the API. Instead of, let's say, products over here, I'm just going to do produce. So if I save this, if I go over here, it gives an error. Okay, it basically says this is the error, get 404 not found. So instead of error, let's say if I do console log not found, and if I save it, so if you see, I get over here not found. Okay, and I can also log the error also if I want to log the error. So let's say not found comma, and then the error, what was the error? So if I save it, so it gives me the error also, not found, and then it says syntax error, failed to execute JSON on response, unexpected end of JSON input, whatever is the error. Okay, cool. Basically the error is this 404 is not found at all. Okay, so that's why when I do console log of the statement, it just gives okay, it is not found. Okay, cool. In order to write it in a more better way, I can write it in this way. Okay, I can write it in. Okay, duct. Okay, dot then and dot cat. So it looks more cleaner now. So this is how basically I fetch a data from an API, right? So it gives me the data, whatever is the data, okay, total and anything like that, and then whatever I want to do with the data, I can do with the data. So instead of logging only the value, I can just log the value dot total also. So because I know the value is nothing but an object, so I can write value dot total, right, and save it. So I'll just get the total, which is 194. Instead of total, I can also write let's say if I just write value, so it gives me value. So instead of value dot total, I could have written value dot products also. So I could write value dot products, save it. So I only get the products. So now with this products, I can do whatever I want to do, right? Got it? Press the insert key. Okay, cool. Okay, thanks. Okay, cool. So yeah, okay. But there is one better way also to write this. Okay, instead of using the dot then and dot catch, there is something called as async await. Okay, there is something called as what? Async await. So async await is basically nothing but it's like a sugar syntax. Okay, syntactical sugar. Okay, sugar syntax or syntactical sugar, right? So it's another way of writing the fetch dot then and dot catch, a more cleaner way. Okay, so I'll give you an example. So let's say for example I want to fetch data from this API itself. Okay, so what I'll do is, so I'll have to create a function. Okay, so I'll just create function get data. Okay, or I'll just write get the products data, get products, and then so this is going to be an async function. So I'll write over here async function get products. So how do you make a function as async function? You just write a keyword async before the function, it makes a function as async function. Very simple, right? You create a normal function. See, this is a regular function. Okay, but if I want to make it an async function, I will just write word keyword async before the function, makes an async function. And then over here I can just write const data equals to I'll just write await. Okay, await and then fetch and then this JSON, this API. Okay, so what is await? Await basically used to await it's basically used to wait till the point I basically don't get the response from this endpoint. Okay, and then I can just do a console.log of the data. Okay, so if I do a console log of the data, okay, and over here I can just do uh, I can just call the function get products. Okay, so if I save this, okay, if I come over here, so if I okay, let me just comment this part for now, the fetch wala part. So if I log this again, I'm getting the same part, right, which I was getting from this line. Okay, again I'm getting the same part, right? So what I'm up to do again I'll just do const over here, let me just write response, and over here I'll just write const data equals to await, and I'll just write response.json. Okay, there's no need to write fetch which again. Okay, and then console.log of the data. So if I save it, you see I'll get the data. Okay, so this is another way of writing it, right? Where when do you have to use await? You have to use await whenever something's going to return a promise. Okay, so this fetch gives a promise. So this promise initially is in pending state, right? So we have to wait till the time the promise is settled, either fulfilled or rejected. That's why we write await over here. Okay, the only reason of writing await is basically you write await only when something's going to return a promise. I know that this fetch is going to return a promise. Okay, so I have to wait till the time it is fulfilled or rejected. Okay, so when the promise is fulfilled or rejected, the result is again a promise. So this response is nothing but a promise again. So what I'm doing is I'm just using await. Okay, and basically waiting for the response. Okay, waiting for basically the data, converting it into JSON, and then I get the data. Okay, so that's why when I call this get products, basically I get what? I basically get this data. Okay, so this is an async await. Okay, and even by, let's say, for definition, if I just use an async function, let's say I just write get data, and I'll just write return over here, return one. Okay, and if I just call this function get data, okay, and if I just do a console log of this function, if I save this, so if you see over here, by default, any async function will always return a promise. Even though I'm returning one over here, what was the expectation? The expectation was to get one as the output, right? Whenever I have a, so this is a function, right? If I write return one, I do a console log, what I'm getting one. This is my regular one, okay? My normal one that I'm basically getting, okay? But when I make this function an async function, right? So now what I get? I get a promise. So by default, every async function will always return what? It will always return a promise. By default, every async function will always return what? It will always return a promise in itself. Okay. So yeah. So this is how basically I can write it. It's just a sugar syntax of this thing. Okay. Fetch. Now instead of fetch, there is a very good thing that you can also always use is called as Axios. Okay, so you can basically use Axios and basically do the remaining part also. Okay, so this is what async JavaScript actually is. Okay, this is what async JavaScript actually is. Now, based on this, basically you can do whatever you want to do, right? Get a data from an API, fetch a data from an API, right? So, yeah, this is what about async JavaScript actually is. There's there is actually a lot to cover, uh, where basically we can make some projects also, but I think we'll keep it for the next part. Okay, in the next coming Sunday or coming weekend, whenever we get time, we can basically do it during that time, where basically we can create a project also. We can just create a very good project by using these concepts and these knowledge that we have basically gathered today about promise, right? There are many things in this. Okay, many things that obviously are there. Again, if you're interested, you can basically join the course and come and watch the course and go through the course, so you'll be able to understand also, right? So I'll finish this session right now here only, where we have covered a lot of things about the callback functions. We understood async JavaScript, right? Callback functions. We saw how to create a promise. We saw how to basically get a data from an API also, right? This is how we can get a data from an API and then use it wherever basically you want to use it. Okay. So yeah, that's it from today. I thought we could extend it, but I don't feel any point of extending the session more. Um, if you have any questions for me, any questions, any doubt, you can basically ask questions. Okay. Whatever is a question related to JavaScript, related to anything. Again, to give you a quick um, walkthrough of this, basically, so we at Geeks for Geeks basically have come up with these sessions where basically you can on every Sunday we are doing these sessions, right? These marathon sessions for 2 hours, 3 hours, right? Where basically we are basically going to undertake everything that comes into web development tech stack, right? Focus is not only on Monstack, we will also be looking at Angular as well. Major focus is basically on JavaScript, making projects in JavaScript. Okay, so this is the third session. We started with basic of JavaScript, we did advanced of JavaScript, then we did today asynchronous JavaScript, right? In the next session, we will make some projects with JavaScript, right? And then we will start with React JS also. right? And then we'll learn basis of React.js, advanced React.js. Then basically we will be learning making projects with React.js. Then we'll be learning Redux. Then we will be learning how to do React testing library also, right? We'll be learning React Native also, right? And then we'll be learning Node.js, Express, MongoDB, what is in REST architecture, why REST architecture is important. So there are a lot of things that basically is in store, right? Again, if you want to learn more, right, learn from a lot of experts, then basically again there are we have these courses, right? We have a lot of courses basically in store that you can basically go through, right? You can just go through this link over here, right, and go through all the courses, right? If you want, I can just put the link in the chat for you, so you can basically just go through this part and basically have a look at all the courses that we have over here. These courses are only related to web development, right? So if you see, there is this FSR, this is a live batch where basically we teach everything from scratch, right? There is live sessions, and then there are recorded courses also, right? And in the live session there are 10 plus projects, but if you see the recorded courses, there are many projects. In HTML itself there is 5 to 6 projects. In JavaScript itself there are 10 projects. In React there are 3 projects, right? There are a lot of projects in this course, right? So even if you learn the basics and everything, and even if you do all of these projects, you'll be a very very good front end developer, right? Obviously, then if you want to go more ahead, then there are good recorded content on Node.js as well, and MongoDB also, which has projects. So you'll be a much better backend developer also. In a nutshell, you can become a very good full stack developer by uh, having this course. And this course is not for 1 month or 2 months. It's a 3.5 months course, which is a uh, very very good, basically, I think, um, part over here, where it's a very 3.5 months course. So you can basically go through this course, right? You can enroll in this course, and you can learn basically from best industry mentors. I basically take sessions, and there are other trainers also. If you see, there is Sumit Joshi, has 12 plus years of experience into only web development. So he's it's a very very basically good part, right? There are courses coming. So if you see, there is starting from March, there is one course. So you can basically register for this course as well, which is coming in March, right? I have an ongoing batch, so there's no point in enrolling it. But you can enroll it. You can basically ask them for specific mentors, and then there are recorded courses as well over here. So if you see, there is course on Next.js, right? There is a course on React.js. Again, this is my course, which I have created for Geeks for Geeks, right? So if you see over here, I'll be over here, right? And there it's a very good course which basically starts from the basics with deep dive, and there are a lot of things. There is Redux also, there is class components, there are major and minor projects also, right? So everything basically is focused on uh, let's say project based. And if you see, there is this demo thing also, why basically React came into picture. So we covered all of those things. And then this is, I think, one of the best courses that we have in JavaScript. I don't say that this is the best course. This is one of the best courses. There are good courses available in the market as well, but I think this is one stop course, right? And you will see a lot of good reviews. And these are not paid reviews. These are good genuine reviews which I get in my LinkedIn, right? And this JavaScript is a very heavy course, right? It is completely basic to advanced, and there are multiple modules. So even if you see, there is this it's a 50 plus hours course where there is a lot of thing in this course. There are a lot of coding questions. There are interview questions. There are machine coding interview questions, right? There are projects. There are multiple projects. I think there are 7 to 8 projects in this course itself, right? Assignments also. There are 19 modules in this thing, right? Everything that I've created, it took me a lot of time to make this course, and I know it will definitely help you. So you can basically go through this course also. I can just put the link in the chat for you if you want this link. So you can basically have this also, right? Okay. So if you have any other questions, you can ask. I'm here. Cool. If not, then we can basically end this session. So I think it was great fun having you all. I think you've learned something. Um, yeah, you can connect with me on LinkedIn, on GitHub also. So I'm there on LinkedIn, I'm there on GitHub also, right? So you can connect with me on LinkedIn or GitHub, and we can basically have we can talk over there also. Okay. So that's it from today. I will see you next Sunday. Bye bye.